All right, so where are my SQL folks? Who queries databases? Great, great. So who uses the replace function? I need to replace some text. I got some other text I want to replace it with. And did you all know that you can actually use it on numbers? Anything that's represented as a string, I can replace a phrase with some other phrase. Okay? Who overuses the replace function? Any hands? No, yeah. Does it look this neat? Does it look like this? Or when you go into ADF or to an SSIS package, does it look like this? Yeah. So my name's Jeff Foushee. I'm a SQL Server database admin. I'm a programmer. I'm a SQL Server speaker. And I do volunteer as a blackjack dealer for Catholic Charities during the summer in Louisville, Kentucky. So today, we're going to talk about a different way of nesting those replaces with something completely different. So with the advance of all this autocorrect and emojis showing up in data, all that data is polluting your database. I got these smart quotes. I got these accident E's. I'm typing resume, and it's like, would you like resume? Okay, and then it drops these accident E's in there. And now when I search for a query that says like resume, or no, resume, it doesn't pick up my resume anymore because it is unforgiving doing a search with that, right? So I want to replace these characters on top with these characters on bottom. Now, this would represent at least 10 plus replace statements to do that, right? So for each one's on the top, I have to replace them on the bottom. But this kind of represents a mapping scheme. So why don't I just build two arrays, one of the before map and one of the after map. Now you see here I've got double single quotes because single quote is a reserved character. So if I want to use it as a literal, I have to double it up. And I can prove that by printing after map. After I've done this, you can do this at home. The slides will be available at the end. You can prove that by printing it out, and you will see that there's only two because I only have two right here. So let's introduce the translate function. I have my before map and I have my after map. So I have this garbage-looking hello with these single brackets, and I want to convert them to parentheses. I have an accident E here, and I just want to get rid of all that formatting. I'm going to select the translate of my literal. I give it a before map and after map, or I could just ram it all together in one translate statement. There you go. 10 replaces, just gone, right there. So let's talk more about the translate statement. Requires Microsoft SQL 2017. This is not a SQL standard keyword, so ANSI SQL won't do it. Stringable, I'm referring to anything that can be represented as a string. Your numerics, your date times, your GWIDs. Case sensitivity. Is it case sensitive? We'll talk about it in the next slide, but then it's going to be determined by the collation hierarchy. Is your instance case sensitive when you installed it? If not, is your database case sensitive when you built it? If not, is your column set to case sensitive when you built the table? If not, did you say in the query, is this literal case sensitive or not? And the number of characters in before map must equal the number of characters in the after map. And it's perfectly fine to reuse characters as targets at the bottom. You can also put them in the source, but it won't do you any good. So, anybody familiar with ROT13 encryption? Remember those little decoder rings you get in cereal, and you'd be like, wow, this is really cool. I could make secret messages. This is just ROT13. So what we're doing here is we're making this super secret encryption of hello, and we're going to pass it to our friend. It's going to say this. And then they have to get out their decoder ring and decode it back to say hello. Oh, the teachers never knew what you were doing. So in this case, we're showing that the before map is all the letters of the alphabet, and the after map is, again, all the letters of the alphabet. But I'm separating them by case sensitivity. Since this translate is not case sensitive by default, I have to explicitly tell it to treat as case sensitive. Because when I hit the first letter H here, it's going to go across here. Found it. U. This lowercase e, if I don't say case sensitive, it's going to come to this e, drop down, there you go. So that's where the case sensitivity does matter. It's going to find the first option, fall out of the loop, and present it to you. Everybody okay with that? All right? So now it's time for a level set. The keywords ASCII and char. So ASCII is going to present a numerical representation of some character. Likewise, char is going to do the exact opposite and give you a character representation of some number. So here I have the letter A in 65, lowercase a in 97. And this is nothing you don't already know. This comes from ASCII codes. So I'm just showing here that I have ASCII code A is for uppercase 65. So char 65 is also a data type. So you could say declare char 65 is equal to char 65, and you will get this insanely long script text of the letter A and a bunch of blanks. So yeah, that can be a little confusing, but that's for another day. So we also have these characters for horizontal tab, line feed, and carriage return. So if you get data that's coming in, like sometimes I get people who just dump data and they'll leave their carriage returns, their line feeds, and their tabs in there. So like we're seeing here, I have this hello with a character feed, a carriage return, a line feed, and a tab. So what if I set my before map to say, concatenate those as my before map and just put 3 dashes in there? When I translate that, they all fall off. That's pretty cool, right? There's also a character for backspace. What if I concat 3 backspaces together? They fell off. How cool is that, everybody? How cool is that? I lied. I got you all, I lied. Because what happens is that, wow, that was anticlimactic. Drop the remote and then fly past all the slides. So what happens is, if you were to take the text from SSMS and put it into Notepad, here's character 8 in actions, these little half boxes right here. Apparently there's no character that will represent the absence of a character. So character 8, the backspace, character 127, the delete, they won't help you. They make these little boxes. Now, somebody might say, well, what about the null character, character 0? I actually invite you to take my slides and try it for yourself, do the same exercise, and watch the results. It's pretty fascinating. So what I can do is I can make this character code of basketballs, and then I'd ultimately have to do a replace and just blank them out with null at the end, or an empty screen. Shoot. So another gotcha that we have here is I'm just going to do a translate like I normally have, but I'm going to select this into a brand new table. So these are integers and a varchar 8. What do you think the data types of those will be when it hits the target table? Anybody want to give me a guess? They will become varchar 8000s. So if you do an ETL and you are pumping this off to the next task, you may notice a slowdown. Spoiler alert, replace does the same thing. So also, I truncate beyond 8,000 characters. So anything like XML, you might want to steer clear of this thing. So what you can do is use the convert functions to convert them back, or try convert. Try convert is a version that will convert, and if it doesn't work, it will just pump out null. Whereas convert, if it doesn't work, the whole thing will just error out, give you no data set at all. So putting it all together, translate is used for a 1-for-1 character replacement. It's inherently case insensitive unless you force it otherwise. It fails at character removal. You're going to have to use replace for those cases. And then lastly, it casts the resulting value into a varchar 8000, potentially slowing down your ETL. With that, I'm going to give you this link if you want to download the exercises yourself and try them out. And I thank you all for your time. Thank you for having me.